All right, good evening, everybody. I hope you're enjoying your solar projects. So the MultiPlus line of inverters from Victron were originally designed for RV and marine installations, to where when shore power is introduced into the inverter, it is directly passed through the inverter to supply power to the loads and charge the batteries if so configured. But when you're in a stationary or a home environment, as soon as you put shore power or grid power to the inverter, you don't want it always passed through. So how do we go about making the change to the inverters so that it'll only utilize grid power once it gets below a certain state of charge? Well, I want to go through and talk about a handful of different ways that you can do this. So let's get started. So I've come across 5 different methods which allow you to determine when your inverters are going to utilize grid power and when they're going to utilize battery power. And some of those even have rabbit holes further down which allow even for more customization, but I'm not going to get into those. But the ones that I'm just going to pass along for reference are: you can enable ESS mode, which allows backfeeding through your AC input connection and supplying power to loads, or even having it grid tied. You can use Node Red, or I believe Signal K is the other option, and that allows for like fine-grained drag and drop programming for really whatever you want. And then the last one is Victron released in their latest update a solar and wind priority option, which allows even those in RVs and on boats, if you have solar or wind, that you can prioritize that for charging your batteries as opposed to grid power. But the ones I want to talk to today, I want to talk to you about the virtual switch, and then show a couple different options in the assistance, and then I'll show you what I ended up finalizing on for the time being and why I ended up picking that route to control when my system uses the grid or when it uses the batteries. So first off, we're going to need to connect to the inverters using the software. There's actually, again, with the customizations in Victron, there's a lot of different ways to do things, so much so that it can actually overwhelm some people. I love the different options for customization. So what I'm going to do this time is I'm going to use the Mark III to USB interface to connect directly to my inverters to view the programming. There are ways that you can download all of your configuration from the VRM, and I'll get into that in a completely separate video as well. But in order to use this Mark III USB device, I have to disconnect these inverters from the Cerbo, because you can't have multiple VE bus controllers on the same bus network, I guess. So I disconnected my cable that was going into the Cerbo, and I'm going to just plug it in to this Mark III to USB interface. Then we're going to jump over to the computer, and we are going to open up our VE bus system configuration tool and quick start on COM3, and it is detected 2 inverters, L1 and L2. So we'll right click on here and VE config multi. So we can see here on the left we've got our connection to our multi. And I want to look at the virtual switch section first. So this is where, if you saw my initial video on my initial look at the software for configuring the MultiPlus inverters, I showed you the virtual switches and how I had initially figured it out to be able to control the AC input. And I believe I had just used this ignore AC input option. And as soon as I check that, you can see we've got a bunch of different tabs on here. So set the virtual switch to on when the load is higher than 4,500 watts, when it's lower than 47 volts, when the volts is higher than 64 volts. So there's a lot of different configuration options in here. And then you can say, all right, well, turn off the virtual switch when the load gets lower. The virtual switches really only give you one option that you can choose from. So you can, drive the relay, you can ignore the input, you can have a dedicated ignore input generator. So you can do one of these options on this screen. There's small customizations for each option, but you're limited to one. And if you want to do multiples of these together, so if you wanted to have ignore the AC input and drive a separate relay, well, you can't do that with the virtual switches. So that's where the assistants come in. And when you come to the assistants tab, after you already have a virtual switch set up, it's going to warn you, as it does right now, the assistant functionality is disabled because you have a virtual switch. So you can either have the virtual switch automatically turned off, or you can have it guide you to where you need to turn it off. I don't really care because I just did this to test, so I'm going to do it for me. So you come to this screen, and you can add your assistant, and you can view all of them. And if you want to control the AC input using an assistant, you will end up using a programmable relay. And actually, you're going to need a programmable relay to turn the AC input connection on, and then you're going to need a programmable relay to turn the AC input connection off. And you'll also need an assistant to basically assign the AC input as the relay that you're trying to control. So we're going to add 2 programmable relays. Remember, you've got an on and an off. And then we're also going to add a general flag user. And the general flag user is what's going to allocate the AC input connection relay as what you want to control. So we've got our 3 assistants here. We're going to select the flag user first and start the assistant. And it's going to give you some basic information as you walk through. And we want to use the general flag to ignore AC input 1. The MultiPlus 2 only has AC input 1. There's not a 1 and a 2. The Quattros have 2. But the MultiPlus only has 1, so we're going to use AC input 1, and that's it. So now, anytime a general flag is referenced, it's going to control that AC input relay. We will start the first assistant, and again, it's going to walk you through some steps. So we want to use the general flag that we've already set and determine when the relay is on, so when the relay closes, and we want to do this based on AC load and state of charge. We don't care about bulk protection and general system failure at this point. So when the load is higher than 5,449 watts for 10 seconds, or when the state of charge is lower than, I think I had it originally set to 15. And that's to enable the relay. Start the assistant for the second one to disable it. We want to come back to use the general flag. Set the relay to off. Again, AC load and state of charge. When the load is lower than, and pick your value, 2,000 watts for 30 seconds. And when your state of charge is higher than 30%. So now we have just created these assistants, which will allow us to control the AC input. And then I still have the ability to come through and add all these other different controls and options and customizations through the software. And we can view the summary by selecting all of them and hitting summary here. So we've got our programmable relay, our general use flag. Set the relay to on when the load is higher than 4,500 watts for 10 seconds. And when it's lower than 15%, we use the general flag to turn it off. And when the load is lower than 2,000 watts for 30 seconds, or when the state of charge is higher than 30%. And you can save these assistants, and then you would hit send right here. And you can see right down here, we've made changes to the configuration. So this tells you that a reset is required when you push these changes out. And then from the assistant standpoint, you would push these changes out to both inverters. So you could save these assistants, push them to one inverter, and then you have to go back in and do the exact same thing to the second inverter. You know, the virtual switch and the assistant worked great for me for a time, but I found that, well, what happens if I want to tweak the values at all? What happens if, you know, I want to raise my state of charge values? I don't want it to get down to 15%, or I want it to be on grid longer than, you know, up to 30% state of charge. And so I started looking into things because I didn't want to have to, you know, get into the software and make the software changes every time I wanted to tweak the values a little bit. And I discovered that I could utilize the relays off of the Cerbo to actually control when the AC input relays on the inverters was opened and closed. And that was using the generator start-stop ability on the Cerbo. There is a built-in generator start-stop assistant and virtual switch for the MultiPlus. But anytime you needed to make changes to those values, you have to get it back into the software. Whereas utilizing the Cerbo, that allows me to make changes from that touchscreen or from the VRM or from my mobile phone without having to get into any software at all. So looking inside my phase 1 inverter, I ran a cat cable from the wiring space down through the trough and over to my Cerbo. And I ended up using a couple of the wires and went into this terminal block up here. And it's kind of hard to see up here, so I'm going to show you right here on the back of this panel. It's got a breakdown of that terminal block. So we've got aux1 and aux2. And so I am utilizing the aux1 connection point for my relay. And so I wired this orange and orange-white are connected into aux1. And they come down here to this terminal block on the Cerbo. So you can see the orange and the orange-white are coming into relay 1. And I have them into the COM and normally closed port of that relay. And so that connects our primary inverter down to the Cerbo. Now we need to go back into the software and actually connect the K1 connection in the phase 1 inverter and basically tell the inverter what that's supposed to do. So if we come back to our software, we can look here and we see I have 4 assistants. Ignore the bottom one for right now, that's something completely different. The general flag user is the same thing that it was in the last one. I'm just saying assign the general flag as ignoring AC input 1. The programmable relay, the first programmable relay, says to use the general flag and set the relay to on when auxiliary input 1 is closed for 1 second. So when aux1 on inverter 1 closes for 1 second, it's going to turn on my AC input connection. And then as I stated earlier, we've got an on, but we need an off. So that's where this other programmable relay comes into play. Uses the general flag, turns the relay off when auxiliary 1 is open for 1 second. And once you add those, you send them to your inverter, and these need to be on the primary inverter. And so now, the relay on the Cerbo, when that is open, your AC input relay will be open as well. And when the relay on the Cerbo closes, that will close aux2, that will close aux1, and then AC input will turn on. And so we've made the actual connection between the Cerbo and the inverter, and now we can go into the settings of the Cerbo and set relay 1 to be the generator start-stop function, which then gives us the ability through the Cerbo to be able to set state of charge values and power usage values for when we want that to start. And so for all intents and purposes, it thinks that the grid is a generator. and it thinks that it's triggering the auto start for the generator. So we're going to come back to the computer here just because it's a whole lot easier to actually record this and see it. And we're going to open up the remote console. So I want to go to the menu. We're going to go to settings. And we're going to start scrolling down to the relay section. And we're going to enter the relay. So relay 1 is, unfortunately, at this current time, relay 1 is really the only relay on the Cerbo that has a lot of advanced features. Relay 2 on the Cerbo is only a manual start and stop switch. I believe it might actually be able to be turned on and off based on an alarm. But if we look here on the screen, relay 1, and we click on it, we've got 5 different options. So it can be an alarm relay, generator start, stop, tank, pump, manual, or temperature. And so obviously we want it to be the generator start, stop. And so we'll now go back 1 page and we'll go up a few options to this generator start, stop section and enter that page. So we see right here the state is stopped because it's not running on grid power or generator power. So looking at these different options, there's no error. It's not currently running. Total runtime. Auto start is if you want to automatically switch on the grid, or if you want it to always be a manual process. I want it to always be automatic. You can manually start this. So you can turn it on and you can actually turn your grid connection on for a time limit. So even today, I had it running for 2 hours because it's nasty outside. The batteries were really low. And so I actually wanted to charge the batteries a little bit. And so I actually turned it on and said, okay, run it for 2 hours. And it was sweet because it ran for 2 hours. And as soon as that 2-hour time limit was up, then it switched back over to battery power. You can run it on a schedule for daily runtime. And then coming into the settings of actually programming how you want this to automatically turn on and turn off. So let's look at the conditions. So when a communication is lost, stop the generator. That's normal. We don't want to stop the generator when AC input is available because the generator is AC input. We do want it to have grid connection when the battery state of charge is at a certain level. So let's enter into here. And so we check the toggle for using the battery state of charge to control whether or not the grid is turned on. And you can see I set when the state of charge is lower than 15%, and they've got quiet hours for running a generator late at night. But I set mine to 15% when the values are low, and stop charging when the state of charge is at 30%. I'm not worried about battery current or voltage because it's all based on state of charge. The AC load. So when the load on the highest phase, so inverter AC out highest phase, is what the measurement is. So you can see you can do total consumption. So when your total system is pulling X amount of power, when your total AC output is outputting a total amount of power, or in my case, I want the highest phase. So when either phase gets to a certain threshold, I want it to switch over to grid power. And so when my output is higher than 4,545 watts, I want it to switch over to grid. And when that condition has been maintained for 10 seconds, and then when the power drops down to 1,365 watts for 60 seconds, then I want it to switch back to battery power. And actually, for the first time that I'm aware of, I believe I actually hit this threshold of 4,545 watts yesterday when my wife was baking in the kitchen. The water heater's going, the well's running, the dishwasher, the microwave, and then I think she turned a mixer on. And that pushed one phase over that limit. And so it ran until it dropped down below that 1,300 watts, and then it switched back over. Seamless switch. No light blinking, no nothing. And then you can set it based on temperature, inverter overload, or a periodic run. But you can see all of those individual values can be changed from the display. And then you've got a handful of other, warm up and cool down times specific to generator stuff that don't really apply to using your grid as your generator. But now I don't have to go in and edit the configuration of the inverter and then push it to the inverter and then have to worry about, well, did I make a change that's going to cause the inverters to reset and recycle? I don't have to, because it's all being done through the Cerbo. And so I can control this stuff through my phone, remotely on any internet connected device if I wanted to. The other nice thing about having the Cerbo maintain this is if we jump back over to this display, there's actually a handful of other nice things. We're going to come back to the main page. So if I go over, so we've got a relay overview here, manual start, manual stop. Auto enable is the auto start. So with one press of a button here, I can automatically make it switch over to grid. So if I hit manual start, and you heard the click, I click manual stop, and it just clicked back over. And then you can also, while you're in the VRM, whether that's the VRM on the browser page, whether that's the VRM on your phone, you can activate some switches which allow for quick toggles in the VRM. So that's this button here in the top right-hand corner next to the time. So if I tap that, now I can see some controls in here specifically related to the generator. Auto start is enabled. It is currently stopped. If I wanted to do a timed run, I can click timed run, enter in how long I want it to run, and then hit start. But I could do that all remotely. So I find it much easier to use that connection between the MultiPlus down to the Cerbo and let the Cerbo make all of the determinations of when my system is going to be on AC power. And that just allows me to be able to make changes dynamically and not have to worry about getting into the software every time. It can all be done. You don't have to have a Cerbo. You don't have to have a Raspberry Pi in order to do all this stuff. You can program it all into the MultiPluses and use the relays built into the MultiPluses. But just keep in mind, anytime you need to change any of those threshold values, you now have to get into the software and push an update to your inverters. I know I've seen a lot of questions and comments on both the DIY Solar Forum, but also the Victron Community Forum regarding how to stop the inverter from using AC input. If you're coming from a different set of inverters that's not, a mobile-focused inverter, you're not used to having the inverters always trying to use AC input power when it's connected. So hopefully this will help. Hopefully the visuals and walking through different things give you the ability to set it up in your own environment as well. So there's lots still to come, lots of different configurations, lots of just customization options that I really want to go through and even test out. The ESS, I want to look at Node Red, so stay tuned. And sad to say, we're getting to the point here in Michigan where temperatures are steadily dropping and sunlight is not as prominent as it should be. So, gotta change things up a little bit. I'll have to go through and adjust my panel angles here at some point. So with that, I'm gonna let y'all go. Y'all stay safe, stay warm, and we'll catch up with you later.